Ever wondered how software systems ensure seamless functionality? Enter the world of functional testing, a cornerstone of software quality assurance. It's all about validating the system against functional specifications, ensuring every function of the software application aligns with defined requirements. So now you might be wondering, what exactly do we test in functional testing? Let's delve into an example to illustrate functional testing in a more real-world context. Imagine a banking application. Here, the login function is put to the test to ensure only authorized users can access their accounts. Then, we have the transfer function, which is tested to ensure users can successfully and securely transfer funds between accounts. Additionally, the balance check function is scrutinized to ensure it always displays the correct account balance. These are just a few examples of how functional testing is applied to ensure the flawless operation of a banking application, enhancing the user experience and building trust. In functional testing, the focus is not just on a single aspect, but a variety of functionalities. First, there's the testing of mainline functions, which are the core aspects of the application. Next, we ensure basic usability, making certain that users can smoothly navigate through the application's screens. Accessibility also plays a vital role, ensuring the system is accessible to all users. Lastly, we verify error conditions, checking if the system responds adequately and displays appropriate error messages. Now that we know what we test, let's examine how we perform functional testing. Functional testing is a meticulous process involving several key steps. Let's delve into these steps and understand how they contribute to the overall testing process. First, we have understanding functional requirements. This is where you comprehend the software's intended functionality. You need to know what the software is supposed to do before you can test whether it's doing it. Next, we move to identifying test input data. Here, you determine the inputs needed to test the software's functions. It's about choosing the right data to input into the system. The third step is computing expected outcomes. In this phase, you predict the expected results of the test based on the functional requirements. The fourth step, executing test cases, involves running the tests you've prepared and observing the results. Finally, we have comparing actual and expected results. This step involves comparing the actual test results with the expected outcomes to identify any discrepancies. There are also various types of functional testing, each with its unique attributes. Let's delve into an example to illustrate functional testing in a more real-world context. Consider a banking application with various functions like login, fund transfer, and balance check. How do we ensure these functions work correctly? Through functional testing. First, the login function is tested. This function is critical as it ensures only authorized users can access their accounts. The testers would input various combinations of usernames and passwords to check if the system correctly allows or denies access. Next, we move to the transfer function. This is where users can transfer funds between accounts. The testers would simulate various scenarios to ensure the function works correctly and securely, such as transferring funds between accounts within the same bank, between different banks, and even international transfers. Lastly, the balance check function is scrutinized. This function should always display the correct account balance after each transaction. Testers would execute several transactions and cross-verify if the displayed balance matches the expected balance. These are just a few examples of how functional testing is applied to ensure the flawless operation of a banking application. By ensuring each function works as intended, we enhance the user experience and build trust in the application's reliability. Functional testing is not a monolith. It comes in various types, each addressing a specific aspect of functionality. Unit testing, for instance, focuses on individual components, while smoke testing determines whether the software build is stable enough for further testing. User acceptance testing, on the other hand, validates the system against user requirements, and integration testing ensures that different components work well together. Regression testing checks for new bugs after changes have been made, while localization and globalization testing scrutinize the software's performance in different locales and cultures. Now, how does functional testing compare with non-functional testing? While functional testing verifies the functional requirements, non-functional testing evaluates performance, reliability, and scalability. Think of it this way. Functional testing ensures your car's brakes, engine, and lights work, while non-functional testing checks if it's comfortable, fuel efficient, and can run at high speeds. Remember, functional testing is about ensuring that each function of the software works as expected, contributing to a seamless user experience. So, we've covered quite a bit about functional testing today. From its definition to the specifics of what is tested, the steps involved, and its various types. We've also explored how it compares to non-functional testing. Stay tuned for more insights into the dynamic world of software testing. Bye for now.